Welcome back to HDTechLogic. In today's video we're going to be fixing a fault with the power on Aurora inverter. Today I've got a special guest as well, my dad.
Hi folks, as HD's kindly introduced, we have got an issue with this Aurora inverter. Now what this guy does is he takes the DC inputs from solar panels that are fitted on the roof, and it takes those solar panel inputs through two sets of inputs, 1 and 2. This power is DC, it comes into the inverter. The inverter's got some power electronics inside it that converts it to AC, and the AC comes out and connects into the grid. And this thing typically sits in the loft or in a cupboard, and it's supposed to work tirelessly. But we're finding after about 6 years a number of these units are failing due to an error E031 code, and that comes up as an internal error. Today we're going to take this thing to pieces, we're going to find out what's wrong with it, see if there's anything obvious, and then if we can, thank you, fix it. So first things first is you need to take the inverter out of the location it's in, and if you feel in any way uncomfortable like that, then this isn't a job for you. It's really heavy, you've got mains power that you need to be disconnecting carefully, and most importantly, when you come to disconnect the DC, this can be under no load whatsoever, and it's actually potentially dangerous to disconnect these because there could be quite high voltage on them. So we're starting off by saying, if you're uncomfortable with any of this type of electrical work, let's just stop now. We are comfortable with this type of work and we want to get this fixed because we're only 6 years into a system that was really designed to last about 20. So first things first is you take the unit off the wall, and on the back of the unit will be a big plate with brackets on. So take off that, 12 screws. When the back plate is removed, you'll then find that we can get to the assembly, the chassis. But before we do that, we need to disconnect some stuff here. So first things first is we need to disconnect the DC. Now these connections are numbered 31, apologies, 37, 38, 39 and 40. So 7, 8, 9 and 0. So I've already taken the opportunity to write on the connector the number, so 7, 8, 9 and 0, and that just means that when I come to connect this later, we cannot get these in the wrong order, and also they come from, in this instance, the center pin. The DC is now disconnected and our mains cable can be dragged through. So I think we've now made ourselves loose here. That's not going to be a problem. Let's flip the unit over, and it's heavy, and start work on the chassis. You've taken the back plate off already. There are 4 screws, and those screws are easily undone. One thing that we must do is keep all of our screws in some sort of order so that we know how to get back to them later. Now you will notice at this point that the back chassis does start to move, but be very careful because there are some internal connections that will need to be disconnected. So my advice now is very carefully flip this up, and you'll see in here there are some connections such as the ribbon cable. These are already disconnected, by the way, in here, we've done this earlier, and some connections at the top of the board which do need to be disconnected. I think it's easier now that we flip it back this way round, because this is the way we're going to be working on this inverter. Like I did at the bottom, I've already been through and I've labelled each of these connectors with the correct number. And again, what we're trying to do here is make sure that when we come to put this back later, all the connections go in exactly the same place. The next job is to remove the circuit board. I've already taken off a number of screws, but let's just finish off taking this circuit board off. There's plenty of screws all around. Be careful. Again, make sure that you keep all the screws in the right order. This is the way that we work. You put the screws in an order that they come out on the bench.
So what do you think's gone wrong, Dad, with this unit then?
Well, fellow YouTuber Andy Reynolds, who we'll link in the description, has been an absolute help in trying to explain how these units go wrong. So big shout out to Andy. You can go and check out his channel. It looks like, from what I've seen on Andy's channel, that one or more of these units called relays get hot and the connections to them that come from the circuit board fail, and that's what I believe is wrong with this unit here. So thanks to Andy, we've got the confidence to have a look at this unit, and I think now is the moment that we are going to flip the unit over, the circuit board, and find out if we can see anything that's wrong. So, have I taken all the screws off? Yes, I have. It's a careful. Oh, well, that doesn't look good, does it? And that corresponds to this area of the circuit board here. So, let's have a bit of a look at that. So, we can instantly see, absolutely instantly see, that we've got a massive issue here. That these positions on the main PCB, the circuit board, have basically been burnt out. So let's just have a quick flip of the board and find out where. Look at that. Okay, so those positions are precisely connected to our relays in this point here. Now, having watched Andy's video already and having understood that this was likely to be the problem, we've gone and bought ourselves 4 brand new relays. And HD, could you do the unbagging of the relays, please?
Okay, so get these open then. As you can see, we've got 4 relays here.
Okay, so let's just double check now. The new ones are the same type as the old ones. So if I just read off the we've got here, it's just not going to get in focus, but you've got the AZ2150W-1AE-12DEFT. Just double checking. AZ2150W-1AE-12DEFT. So these are as ordered the correct relays. So at this point, what we need to do is perhaps clear some of our space on the workbench, because I don't believe that we've got anything hopefully wrong with the rest of the inverter. But while we're here, we'll just have a quick look. It looks like we've got a front panel board here. This is what drives the display and the various push button switches. We've definitely got some sort of microcontroller here, which will probably be due to monitoring what's coming in, what's going out. There looks like there's some sockets as well on the side. So should we see if they've been labelled with anything? Oh, they have. So it looks like there's a program import and a inverter program import. So there we go. And finally, this will be the actual power electronics, this is what takes the DC and converts it into AC, and there's some filtering here. So this is probably the heavy part, so I will remove this now away and we'll take this out of the equation. So now we're in a position that we can actually start working on the main circuit board. Now we've identified that these relays are troublesome. Other YouTubers such as Andy have identified this in their videos, and we can see from our circuit board that some of these relays certainly have got very, very hot and the circuit board has perished. So I think the easiest thing we can do is 1, 2, 3, 4. Let's just replace all 4 relays, and then we can install the unit back in the loft and hopefully get another, many years of service out of it. So I do understand that you might want to take these apart and clean them, or otherwise try and make some other repairs, but I think for us we're going to just replace all 4. So let's identify the pins that we'll need to desolder, and I think it's very obvious. We are very, very obvious. This one's going to go, this one's going to go, this one's going to go. What other pins? So we've got, that's a relay coil, that's a relay coil, that's a relay coil, that needs to be unsoldered, and then we've got more. That's a problem here. I don't know what that is. Is that also a relay? Yes, it is. It's also a relay, just flipping it over. Yeah, so we've got the relay coil, so these are definitely problematic. And finally we've got this one as well. This one here doesn't actually look all that bad, but as we said before, we're going to change it. What I suggest you do now, guys, is use something like a flux pen. Flux is a chemical that, or a liquid that helps solder flow, and so what we want to try and do is make the job of taking these relays off the board as easy as possible. So if we pop some flux down, that's going to make our soldering job definitely a lot easier to do. So just blobbing a little bit of flux on all of those, especially these damaged ones. That will really help us unsolder. Okay. The next thing is that you really do need a decent soldering iron. Your small electronics iron is not going to cut this. So we are using an Antex 80 watt soldering iron. That's got plenty of power, and if we just put some solder on there, we can see that that's doing the job great. Now I will use a device called a solder sucker, which some of you may be familiar with, and what we'll try and do now is try and unsolder these using the solder sucker. Quite a lot of heat that gets soaked into these circuit boards, so you want to put a lot of heat into the joint before trying to suck it out. And I think that what I might just do is have a little bit of solder myself to ensure that these desolder. Yeah, they definitely need a lot of. They definitely need a lot of heat inside these joints, guys. It might be counterintuitive to add solder, but believe you me, for desoldering, it does actually make a lot of sense. Try not to breathe this smoke in. Not really good for you. But we are working in a very well ventilated outdoor shed with the windows and door wide open, so don't worry too much about the fumes today for us. We're taking quite a lot of junk out of here at the moment, so what we need to do sometimes is just to clear the solder sucker out. You'll find that it keeps the action much better. we'll carry on. Let's do this one now. There's another item called desolder braid, and this is going to help us take the last of the solder out. So just so we've now desoldered the first one, I think. So if we flip this over, carefully does it. You can see evidence of damage. So we've unsoldered that quite cleanly. What we will need to do is go in with the flux pen on the top now and just make sure, absolutely sure, that we clear off any residual solder from these positions here. Now, one of the interesting things I'm already noticing is that some of these holes on the circuit board are bigger than the relay pins, and that causes us a potential problem because it relies on the solder joint to make the connection, which of course it will do. But what would have been better is if these holes were maybe slightly smaller, so they actually matched the pins. I see these are square pins on the relay and round holes. So yeah, okay, we'll take off the other relays, guys, and see you back in a second. So we've taken off one of these relays. I think for identification purposes I'm going to identify this now. So if we look at the board, this is saying 1S 1P. So if I just put 1 here, I wonder if the others will have a different name. We'll see. But anyway, that's definitely number 1. Now number 2 relay, yeah, that's ready to come out. Just a little bit of encouragement. Be very careful. We don't want to pick off these tracks. Just a little, oh, that's it. That's become. Wow, 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 wow. So these relays are really suffering on this pin, and that's making it look very, very dark. So what this one's got no identification. So anyway, this one is number, so let's just write 1, 2, let's write 2 there. So what I'll do as well, I think it's very important that we just try and clean off these joints as best we can. Now we can get to them. So again, with the solder braid, and sometimes it's just worth giving, the flux is really your friend here, give as much as possible. So let's try and clear this off, this junk off as much as possible. Lots of heat, lots of solder braid, get in there, that's it, suck it out. That's, oh, it's looking quite bad, that joint actually. That's not great at all. So this is going to need quite a lot of cleanup. Go back to this one because this one's really. Okay. On to relay number 3 now. Let's give it another round with the desolder braid. I've gone round this a few times now. Okay. Again, being very gentle. Let's see if we can get this relay off. Yeah. It's going at the top okay, which is good. And can we get it to come off at this point here? Yeah. Yeah. And off it comes once again. So if we identify this as 3, 3, we'll have a look at these relays a bit, but can you see a pattern forming here, folks? Not good. Let's tidy off this one as well. Okay, so that's the 4th relay off. This one didn't come off as clean. So you see they've used this conformal coating, which is like a clear paint. Some of that paint's got under here and actually stuck on the relay, but interestingly this relay, it's got some damage, not really as bad as the others. So okay, so the next thing we need to do is we're going to clean off all of these joints one more time, and then I'm going to go around with IPA and clean all the circuit board off, both front and back. So join us for that in a second. So next part of the journey is to clean up this circuit board so that we can solder in our new components and actually also get the chance to see what damage has been done to the circuit board. Now I think from what I see so far, we're okay. The circuit board appears to be relatively okay. It's a bit caked and it's a bit black in places, but what I'm doing for the moment is I'm just going round. This is the initial clean with a cotton bud soaked in isopropyl alcohol, commonly known as IPA, and it's a very, very useful cleaning solvent in many industries, but specifically in electronics. It does a great job of cleaning up stuff. It's quite gentle. It won't, for example, rip off all of the writing of the silk screen. That would be a bit of a problem. There is another chemical that we can use, something like a carb and choke cleaner. This one is based upon a chemical called toluene, and this is much more aggressive. So I'll give you an example of the toluene. I mean, it cleans it really, really aggressively, but the problem with the toluene is it'll almost certainly start eating through the silk screen printing and also the PCB coating, the green coating that goes on the circuit board as an insulator layer. So I would recommend using the IPA. Be gentle, take your time, and let's just clean this up. And when we've cleaned all these pads up, we'll be ready to consider how we start soldering in the relays again. Okay, so now we've gone around all of the joints and the points on the circuit board, and we've really tried to clean them up with a solvent, so they're basically clean, and that's going to really help us now when we solder the new relays in, that they are making a great connection. The other thing that we've noticed is that, and you can see this, the holes on the circuit board are round. pins on the relay are very much square, or certainly squared off, more like little rectangles. And as you can see, that when the relay goes into the circuit board, I flip this over and we get a good look at it, there is a lot of gap between the pin and the hole. Now these holes contain something called a via, which is a connection that takes one side of the circuit board to the other. Now even without the relay, you can see there are other vias, pads of 4 vias close by, and this whole area is getting hot. So I actually feel that the amount of vias is probably under what it should be, and because these pins are square, there's a lot of sort of solder to fill the gap, it's not making the best connection. So I have a suggestion, and this is what we're going to do. I haven't seen this done elsewhere, but I think it's a good idea. We're going to go for it. We're going to take some solid core single wire, and just to show you by example, if I push this solid core wire through the hole, just do that, and then I put our relay in, interestingly the relay goes in absolutely fine. So there is enough gap that the solid core wire will fill it out, and I believe that will absolutely improve the connection and the conductivity between the pin of the relay and the circuit board. So now what we're going to do, we're going to go and prepare some small jumpers, some small pieces of wire, because what I'd like to do, for example, these points here are on the same track, so we're going to make a small piece of wire, in fact I've already done it, that will go in, for example, there. There's another one here which we can do. You get the idea. Now the ones that are by themselves, what we'll do is we'll make some short right angle pieces, and we'll make sure that they stick out to the side of the relay or somewhere that we can easily get to it, and that we can trim them back to make them nice and neat. Right, we've decided that we're going to solder these relays in one by one. So what you can see is we have this extra piece of wire coming across to bridge the truck. That's definitely going to help. That's going to take some of the stress off of the circuit board, and also it's going to help the via. You can see I have a tiny little piece of wire popping out of that side. I don't think that's worth worrying about, I really don't. And the coil wires are popping through fine as well. So we're going to flip this over so that we rest the relay quite solidly on, and that is nice and poked down. So at this point I think we are ready to make some soldering. Now I will just add a little bit of extra flux just to aid the jointing. We will clean our soldering iron bit.
Wait, it's not phone.
So now we're ready to make some solder joints. So what we'll do, we'll just go and put a little bit of flux on the new joints, give maximum opportunity for the solder to flow. We're using a really good solder. People that are in the industry will know very much about this particular solder brand. Let's go for it. So plenty of heat. That's what we need on this job. Plenty of heat. We're not going to rush anything here, okay? We're going to let the solder flow. I would not normally be so liberal with the solder, but on this occasion we absolutely want a great connection. Okay. this track ends up connected here. So what we'll do on this instance, we will actually make a connection point around here like that, and that will actually sort us out really well for this relay, and that's going to help a great deal. We're also going to solder this one, and that's going to improve the conductivity onto these pads. So very much like before, solder in second relay. Now at this point we've made all the solder connections, so we've got 4 relay coil soldered in there, and then 4 sets of main contacts, and we've doubled up where we can the contacts with extra wire. Time will tell if this has been a successful repair, but at the moment what we'll do now is we'll go back around again with the IPA. Just go and take some of this black off. Okay, so now we've got 4 new relays soldered in, and we've also taken the opportunity to add some copper to the circuit board with these extra bits of solid core wire. Just if you're interested, the solid core wire that I used is the standard type of cable that you'd get in electronics hobbyist kits. I'm not really sure of the cross-sectional area, but it's tinned copper solid core wire, and I think it's worked really well. So the next thing we need to do is to install that circuit board back into the inverter. So what we will do is just clean this off, because we don't really want the evidence. A little bit of foam cleaner always works well. Doesn't actually want to take it off though. Fair enough. Okay, well, can't try any harder than that. So we've got our connections at the back, which we're going to move out the way. This is all tidy. Just one more chance to look at the circuit board, and it's all alright. Clean. Okay. So we need to make sure this insulating sheet's in there. That's actually got hot in its time. That's crinkly. That has got quite hot in its time. Hopefully it will not get as hot as that again. Okay. I never try and do the screws up really tight on the first insertion. The reason being, if you do that, then the thing you're trying to screw down obviously is tight. So if you're marginally out, or you've not quite put the circuit board or whatever you're screwing into the right position, at which point it can get really difficult to put those other screws in. So leave everything loose, just put all the screws in, and then go around and make absolutely sure all of them are tight afterwards. So we're nearly there. So now we need to connect these back up again exactly as they were. So remember, I had written on these what they were. So we've got number 1, and make sure they go in with a nice positive click, as we do. They're all nothing's trapped. The fan's in. The next thing we need to do is pop this plate back in there. Very careful that nothing is trapped. Let's just pull this through a little bit. There we are. That's better. Now, the next thing is that this ribbon cable needs to be connected back here. Now, nice and gently. Do not bend any pins here. Okay, we're in no rush. We'll take it really easy, and that goes in beautifully. And of course, these two little clips at the end clip over. Make sure it's done well there. Don't trap anything. And now we should be in a position to do the back 4 screws. We now are in a position to connect the DC for the solar panels, but let's first just make sure we get our grid cable routed back through the cable gland. Nice and neat. Okay. And now remember, we labelled these earlier. So this one was 37, hence the 7, and it came from the middle. So 7, nice and tight, it's gone on beautiful. This one is 9, which is that one. So now that one must be 0, and that's. So this was really important to label these guys, because what you can see is actually looking at the length of the cables. It's not 100% obvious which is which. So that one says 9 and that was 39, which is that negative there. And this must be 0, which is 40, which is this one here. So, just double checking. That's in. That's in. That's in. And that's in. The grid cable is nice and tight. We haven't really disturbed that, so I don't need to play around with that today. And the final thing that we're going to do now is we're going to give it some juice through the mains, but we haven't got any solar panels to test it. So when we first brought this back to the workbench and powered it on, we had absolutely nothing on this display. Absolutely nothing. Nothing whatsoever. I am expecting this time, when I connect it, to hopefully get something on the display. If we get something on the display, that means that we've actually improved the situation, and I have a high degree of possibility that when we get back and install this into the loft, it will work perfectly with the solar panels. So let's go and connect it up. Okay, here comes the moment that we've all been waiting for. I will go and connect this, and we'll see what happens. Absolutely nothing. Okay.
Well, that was a total disappointment, wasn't it? We were expecting to see life in the Power 1 Aurora inverter having done all that work, but was it a total waste of time? You'll have to find out in our next video, part 2. Be sure to check it out to see what happens.